How about that?
That's great.
Good. Okay. Sorry for that. Yeah. So again, thanks for inviting me to participate in this. I look forward to learning a lot myself, and hope the few remarks I have here will help orient you towards the issues in contact tracing that I see, and in particular relevant to the themes of this conference: algorithm design, law, and policy. Uh, Law and policy are not my areas of expertise, but I will make a few remarks at the end about those particular issues. The outline for the talk, I'm going to have one page on disambiguation because PACT is ambiguous, and then talk about contact tracing, both manual and digital, and then talk about one of the key technical problems with digital contact tracing, which is measuring distance with smartphones. Talk something about privacy and integration with public health, and then one of the key issues for getting these things to be useful is having a widespread adoption, talking about that. Talk a little bit about effectiveness of the contact tracing apps. What does it mean to have effectiveness? How do we think about that? Talk about some law and policy issues, and then conclude. And I'll be happy to take questions. I guess we have a question session after Helen talks. So, but thanks again for inviting me to participate. So the disambiguation page. The project at MIT that I'm most involved in is PACT, and that stands for Private Automated Contact Tracing. We have a webpage on that, which you're invited to look at, pact.mit.edu. But there is also that's PACT East Coast, and there's also a West Coast PACT, and we've had some discussions about which of us should change our name, and we decided neither of us should because we do enough different things, although they are closely related. So anyway, when I say PACT, I mean PACT East, but just be aware that there's a PACT West. So what is manual contact tracing? So I'm trying to fight a pandemic like this. Manual contact tracing works by as follows. When a person, what is usually called the index case, the person that's found to be positive with a test, of PCR test, say, then you want to find all of the, or most anyway, of the people that he may have exposed, and those are called contacts. And that's called contact tracing, and that's traditionally been a manual process by starting off with, once the person tests positive, having an interview with a disease investigator, they're sometimes called, or a contact tracer. Then once the index case lists people that he may have been close to over the last period of infectiousness, which could be up to a couple of weeks maybe, they start calling the contacts and trying to find out if they're showing symptoms, advising them to get a test maybe depending on the situation, advising them to quarantine themselves and so on. So that's where the interventions start. So the contact tracing is intended to prevent the spread of the disease. It doesn't help the index case because they've already tested positive, and the contacts are sequestered if they've already got it. So it's not helping them either, but it may help their family or other people that they contact. So this allows contacts to be quarantined, symptom checked, and tested. And it's a powerful method for flattening the curve. It's been used in many different pandemics going way back, much before technology came to the play here. And it helps remove infectious people from circulation. That's the key point. You stop the spread of the disease by having infectious people not circulating in the general population and not infecting other people. So the limitations of this are speed. It has to be done quickly to prevent infected people from walking around. Compliance, people may not pick up the phone to talk to the contact tracer, or they may not give truthful answers, or they may, for various reasons, and they may not remember some of the people they were near. They were on the bus, and there were people sitting near them on the bus, so they just don't know who they were. So manual contact tracing has its limitations. Now that we have smartphones and everybody's carrying a smartphone, a lot of people are carrying smartphones around, we can try applying technology to make this process a better one. So my own involvement in this came about when I was teaching with Yael Kalai, who many of you I'm sure know, last spring, a security course. We talked about the Apple Find My protocol, which is designed to help you find a lost phone. And this is a very clever protocol designed by Apple, and it uses Apple devices and Bluetooth technology to help sense proximity between pairs of such devices, say two phones. And the phone broadcasts values. These values change frequently for privacy protection. So you can't just say, I've heard this person's phone because I know what they're broadcasting. That changes every few minutes. There's lots of other protections for privacy there. This is a very clever protocol where Apple itself does not know which phones were near other phones. There's a public database, nonetheless, that Apple maintains, which allows the owner to find out where the phone was last seen, and that location information was encrypted with the public key of the phone that was lost the last time it was seen or heard. So the PACT protocol is similar to that. The idea is, well, if you can use Bluetooth to measure proximity for this kind of application, why not for COVID-19 contact tracing? So we can have the phone broadcast chirps that change every so often for the same kind of privacy issues. And then other phones can listen in and remember which chirps they heard. If the owner tests positive for the disease, then he can upload to a public database the seeds, the cryptographic seeds for generating those chirps, which is basically posting all the chirps he broadcast. And others can then download that database and check in a decentralized manner if they've heard chirps of infected people. So they determine on their phone themselves whether they might have been infected. There's no computation done at the central database to identify the potentially infected people. It's done locally in a decentralized manner. This is one of the privacy features of such protocols. There are many variants on these ideas. DP3T in Switzerland, TCM, and others have developed protocols, and lots of academic literature evolving on this stuff. But these are the main features where the phones are broadcasting chirps. Other phones may be, if near enough, recording them, and then checking later to see if the infected person has posted what chirps he broadcast after that infected person has tested to be positive. There's lots of countries rolling out such apps at the moment. So that's the main idea of digital contact tracing. We formed a team at MIT first, and then expanding out from that to look at these issues and these possibilities. It's formed in early March on the MIT campus. Myself and Danny Weitzner, the leads are myself and Danny Weitzner. Danny was at the White House with Obama and is co-leading this along with Mark Zisman and Israel Soibelman from Lincoln Lab, leads out there, and Dr. Louise Ivers from Harvard MGH. So we've been working together to lead it, but it's a big project. And there are many organizations now represented in this, MIT, Lincoln Lab, of course, MGH, but the Weizmann Institute, BU, Brown, IBM, Carnegie Mellon, MITRE, Northeastern, whatever. It's a big, long list of organizations that are all participating together, very open collaboration. We're all trying to have some positive public health impact, and we're not worried about academic credit much or other things like that. It's mostly trying to, what are the good ideas, what works, how can we make this happen? More than 100 people involved locally in Boston, and we're particularly strong on what we call layer one, which is the Bluetooth ranging thing. How far away are the two phones from each other? Because that's one of the challenging questions, as I'll talk about. But we have strong relationships with other teams, Apple and Google in particular, is helping with some of the foundational implementations, other vendors, jurisdictions, various states or cities or universities, even public health authorities in various places. So a lot of people talking with each other, trying to figure out how to make this technology work. And our role is primarily as a technology as evaluator and advisor. We're not developing apps, although we might help develop protocols that go into the apps. We're most interested in trying to help good things happen by coordinating and evaluating and discussing with people, rather than taking credit for things, saying this is what we invented or whatever. It doesn't matter who invented it. We're trying to save some lives here. So one of the key technical questions, too close for too long accuracy, measuring distance and time. Time is pretty easy, so distance is the challenge. The CDC says too close for too long should be less than 6 feet for more than 15 minutes. If you're within 6 feet of someone for more than 15 minutes, you've got, that's a too close for too long event, and you may have been infected and you need to get tested or have some other intervention applied. And so it's the 6 feet measurement that's the hard one. The 15 minutes is easy. So Bluetooth is used for local communications, and it's good up to maybe 30 meters, 100 feet or so, depending on the environment. So can it be used for ranging? Can you measure the 6 foot distance accurately, even if your devices communicate much, a fair amount more than that? I mean, it's local, but local is local, and local technically for radio and local technically for the virus are maybe different things. And so as a theoretician, I thought this would be a piece of cake that, radiation strength falls off quadratically with distance, and you just measure the received strength, and that would be it. The world is in no way that simple. Here's a picture of two people carrying cell phones, the index case on the left and the contact or the potential contact on the right, and you want to measure if they're within 6 feet of each other. And so the phone on the left is broadcasting these random values that we call chirps, and the phone on the right is recording them. And later on, if the infected person gets tested, then they can post the chirps that they broadcast or the seeds to generate them. So the question is, was that a close contact or not? And you can measure the received signal strength on the contact's phone. This depends on, it turns out, an enormous number of variables, starting with the models of the phone, I suppose, first. Different phones broadcast at different strengths. So the transmitter power is a function of the model of the phone, also to what the transmitter power was set to on that phone. The phone orientation matters. These antenna are not isotropic. It depends on which way the phone is oriented. So if holding it one way versus holding it another way can have a great impact on the strength of the received signal. Whether it's in your pocket or not in your pocket can matter. Whether it's indoors or outdoors. Indoors you might have signals bouncing off the ceiling and so on too, so the strength is stronger. Outdoors it's less strong. Maybe the phones can tell whether they're indoors or outdoors. We should factor that into the computation. Those are questions that are being considered. Perhaps one of the more important questions is, where is the person's body relative to their phone? Because these signals do not go through water very well, and people are just big bags of water. So that's an issue. It could make you seem like you're much further away when you're not, if the body's in the way. But walls, on the other hand, tend not to absorb this signal. So you can't tell if two people are maybe within 6 feet of each other, but they happen to be on different sides of a wall. And there's no way of detecting mask wearing and other things like that, for example, too, which probably should factor into these kinds of things. So this may be the biggest technical challenge for Bluetooth-based contact tracing, how to measure distance. And because it's such a hard problem, and because there's also a lot of noise, we put a lot of work into this. So one is the sampling rate, the reception of these signals takes battery power, and you don't want to turn on the receiver all the time. So how do you get enough samples? How do you schedule the listening so that you're not draining the battery too much? The Lincoln Lab folks have put incredible effort into this problem. There's a nice paper that just came out by Gary Hatke and colleagues at Lincoln Lab, which gives a lot of the details. Now I've got the here, so just search for Hatke on the archive site, and you'll find the details. But there's, the answer is, can you tell it? Well, it depends. It depends on what information you have about the parties, the way they're holding their phones, and so on too. Mostly. Here's a couple of robots that are cute that were used out at Lincoln Lab for doing some experiments. These robots are turtle bots. You can program them to wander around and swing around and do a little dance. And there's even a YouTube video set to music that you can watch them do their dance and get within 6 feet sometimes and so on. So I'm gathering a lot of data. There's a data collection coalition which collects this kind of Bluetooth ranging data with many parties participating. There's even a NIST challenge contest for applying machine learning and other technologies to this too close for too long problem. And there's a website that if you just Google for NIST too close for too long challenge, you'll find the data there. So you can download data sets, you can try your best machine learning algorithms and see how well you can do at guessing what the real distances are given the data that's there. And you might have a sequence of data that was received because you've got some periodic sampling going on as you're gathering the data on the receiving phone of what was transmitted by the sending phone. There's other technologies available, having fixed beacons, not phones, having wearables of various sorts, using ultrasound or ultra wideband instead of Bluetooth, but Bluetooth is the main technology we've been looking at. So that's the technical, one of the main technical challenges with implementing this. There's also privacy concerns, which I'm happy to say seem to be more in hand, although it's not totally in hand perhaps. You can have various principles like no phone data should leave your phone without the user consent. You don't even have to download the app. It should be voluntary. If you do download the app, you don't have to turn it on. If you do turn it on, you can just put it in listen mode and not upload mode. If you're infected positive, you maybe have discretion as to whether you upload the data that generated your chirps or not. And when you discover that as a listener, you may have heard infected chirps, what you do about that may be discretionary for you too. So a lot of user consent points here that help people be comfortable with the privacy guaranteed by such an app, in the sense that nothing leaves the phone without their consent. Also, there's no usage of the GPS location in most of these protocols too. GPS is, as you can imagine, very sensitive from a privacy point of view. And so these apps measure proximity of one phone to another, but they don't measure where you are by using GPS. So you can say, this phone was maybe close to some other phone or close to some phone of an infected person, but it won't say where you were. It can't say you were, which town you were in even. The phone broadcasts these changing pseudo-random chirps, so there's no tracking just by listening to the chirps. And the phone records chirps that is heard, as we talked about, and then you get seeds posted for the chirps that were broadcast by the infected person. So that's again, a point of discretion. The user may decide they don't want to be compliant. They tested positive, but they don't want to be a good citizen. They don't want to notify anybody they may have been near. Maybe they were near people that they don't want to reveal or something like that. Or, it's not even that, because it's the chirps, right? But they may feel that they're revealing the people that they were near. So the phone of the listeners can match locally against the posted database of infected chirp seeds. And there's no need for the central database to store any personal information. There's no phone IDs necessarily, or any location information, of course. It's just the chirps and the fact that these are valid chirps or chirp sequences posted by people who later turned out to be infected. So once a phone determines that it has heard a chirp by a person who later was infected, they can then be alerted and maybe have a discussion with a manual contact tracer, be advised whether they should stay at home, watch for symptoms, get tested, et cetera, et cetera. They have to be integrated into the public health system. And that's one of the key design points still being worked through, is how to integrate digital contact tracing with the traditional manual contact tracing. There are some active attacks that can be played against these protocols. For example, you can listen to a chirp and then replay it somewhere else, relay it to be played later. So play it later, or relay it to play it somewhere else. So there are ways of doing some of that, and you have to think through the consequences of that. But there are some extensions of the basic protocol for dealing with some of those. But there are some potential privacy aspects having to deal with those as well. How to integrate with public health? I think the main point to start off with is, what's your goal here? The goal is not to replace manual contact tracing, but to improve and extend it. You're going to make it better. You're not going to get rid of the manual contact tracing. Manual contact tracing is very important for lots of reasons. For one thing, having the contacts talk with a public health worker allows them to learn about social services they may need. How are they going to feed themselves if they're quarantined at home? What kind of social services allow them to take care of childcare or something else? There's just lots and lots of ways in which just being alerted by an app on your phone is not adequate. So just what I said. So the digital contact tracing process should feed into the manual contact tracing software, and most jurisdictions have some sort of manual contact tracing software. It may be as simple as an Excel spreadsheet that they're typing stuff into, or it may be a more complicated Salesforce kind of thing, or some other product. So the goal here is to have digital contact tracing make manual contact tracing both more complete by finding contacts that the person can't remember, that person on the bus, say, or making it faster because maybe the alert allows the contact to call in and be notified and advised as to what they should do quicker. So speed and completeness are the two criteria for success here. To make it work effectively, adoption can be a challenge. People need to download these apps and install them. And I note that both parties need to be running this digital contact tracing service. If my phone is broadcasting, it doesn't do any good if your phone doesn't have a capability of receiving the chirps that my phone is broadcasting. So if we only have a 50% adoption rate, only 50% of the phones are running this kind of service, then maybe only 25% of the contacts get logged, because 50% chance that I have it and 50% chance you have the app, and so the product of those two is 25%. So the fraction of contacts that get logged this way may be small if the adoption rate isn't really fairly high. By fairly high, I mean 60, 70%. To help with this, Apple and Google have done a wonderful thing. They've gotten together, and because some people are going to have Apple phones, some people are going to have Android phones supported by Google, and so they've announced a protocol, a common protocol, the Automatic Exposure Notification Protocol, AEN, that's built into the operating system of both Apple and Google, and this allows for interoperability between Apple phones and Google phones, the Android phones. And this is a huge and very welcome development. I should give my thanks here to Apple and Google for making this happen. That's just a wonderful step forward. Without that, the apps don't work well together, and they have issues with battery drain as well, because if it's not built into the operating system, they tend to go to sleep when they're not running in foreground mode and so on. So Apple and Google have done a wonderful step forward here. And that's built into the operating system. Apps get developed on top of that and need to make use of the API that Apple and Google provide. Nonetheless, people may resist adoption of the apps because they fear Big Brother. They may have concerns about privacy. They may misperceive what the privacy properties are of the app. They may be concerned about the police somehow making use of this information, or ICE, or the housing authorities. They've got too many people living in the house, etc. They may have a confusing UI. For example, the Android, at least one of the early versions of the Android app, allows for location services permission, which sounds like it's using GPS, even though it's not. So there may be resistance to that. But nonetheless, there have been rollouts of these apps in a number of places, most notably in Europe. Switzerland, for example, is doing well. Germany, Denmark, and they have app adoption rates which are going up, but are still tend to be below 50%. And they have huge campaigns with celebrities saying, we're using this app, and having lots of people pushing for it. And it's hard to get the adoption rate up. So that's another challenge that we have, not a technical challenge, but a messaging challenge or effectiveness. And then you can ask the question, does digital contact tracing really help? Even if we got over those hurdles, can it save lives somehow? And some studies with models show that, yes, it could help. If you had a contact tracing mobile phone app, it could stop the epidemic if it's used by a sufficiently high proportion of the population. This is a quote from a paper by Ferretti et al. In Science in May. So some of the modeling studies, and it's not clear how much weight to give to these modeling studies because they all make assumptions, and one doesn't know whether the assumptions are the right assumptions or not. In any case, we're starting to see real results now. And in Singapore, for example, they have a digital contact tracing app that does reveal new contacts beyond those found by manual contact tracing. So we're seeing some positive results happening there. And again, it may allow for faster alerts of duplicate contacts. Digital contact tracing is mostly about finding people, for the new contacts, finding people you don't remember seeing. And so mask wearing may decrease the amount of public transmission. So it may decrease the number of strangers you infect, and therefore decrease the utility of digital contact tracing. So there's been no studies whatsoever on that. Here's a little diagram that I'd like to put out to help you get oriented. So this is, it's got made up numbers, but they're sort of plausible numbers, I think, depending on the context and the state of the world with amount of infection. So here's 100 people represented and divided into really four categories with a one outside. So 60 of those 100 have no relevance to this particular index case that's been being looked at here. Of the people that index case has been near, maybe 5 of them, there's 5 in this little small circle here, have been infected. Manual contact tracing finds 23 of them, of which 3 are infected. So manual contact tracing is fine. And that's a typical number for manual contact tracing. You call up 23 people and you find 3 of them, when they're tested, they turn out to be infected. Digital contact tracing finds maybe 33 people, of which 3 are infected. And the key points here are that digital contact tracing is discovering a new contact. There's one person the person in pink here, discovered by digital contact tracing. And that's a benefit that we didn't have with manual contact tracing. That person was not found. That person can be advised to quarantine and stay off the street. The green section corresponds to people that are found both by manual contact tracing and digital contact tracing. There's 17 of those, and they can get faster notification perhaps if the app tells them first that, be careful. So talk to your manual contact tracing folks. You've been alerted. So what are the legal questions? I'm not a lawyer, and I'm not sure what the best questions are, but to me, the interesting legal questions might be, to what extent could law enforcement access or use any of this contact tracing information? There's precedent for these kinds of questions in the manual contact tracing world. Medical information tends to be very much protected, and access of, I'm not sure the legal questions actually differ that much once you've got digital contact tracing. It's the same kind of information, more or less, but I think one needs to look at the details. And do we need to update the laws in any way concerning protection and sharing of medical data for handling digital contact tracing data? There is this public database where these chirps get stored, just what needs to be the law regarding those, for example. Policy questions. An interesting, very interesting one is, should the app use be made mandatory? Can you require that people download and run such a digital contact tracing app? The scenario I've been painting here talks about a very voluntary kind of situation where everything is discretionary, even downloading the app is discretionary. But in China, various kinds of app use have been made mandatory. And one can imagine the world drifting in such a direction that jurisdictions or services or businesses or schools start demanding that an app be used, and you need to, well, mostly this is even more for symptom checking kinds of apps where you're showing that you haven't had any symptoms recently, but because proximity detection has got a delay built in. It doesn't it's not until the infected person tests positive that you actually get notified. But still, you can imagine some kind of mandatory requirement for various kinds of apps relating to COVID-19. One of the interesting questions also is that there's a tension between public health and the desires of public health officials and privacy. And this is a tension that occurs in the manual contact tracing world as well. So some of these issues are not new, but in general, more information revealed to the system may improve public health results at a cost of privacy. For example, if you added GPS data to your app, well, maybe you could track people better and find out who they were near better and stop the disease more quickly. So there's a push from some folks to say, yeah, we should have GPS data. You'll see some apps come out that use GPS data. I'm not a fan of that because of privacy reasons, but there's that tension between public health and privacy over the use of GPS data. Another question that's related is the question of who infected me. If you're notified that you may have been infected, you may want to find out who it was that infected you or might have infected you. And that's a question that comes up with manual contact tracing as well. And contact tracers tend to be very good at not telling the contact who it was that might have infected them as a matter of privacy. So that's precedent there. But again, there is pressure to develop statistics about what the graph looks like of infections and so on too. And so there's pressure to try to get more information out of the system than good privacy policy would allow. And then there's a question of who decides on policy, government or high tech or public health, somebody else. Right now, it's a very interesting situation with Google and Apple having set some privacy limits on what these apps could do. They provide an API, which if you use it, comes with restrictions. You can't build an app on top of that API that gathers GPS information, for example. You can only use an app that's approved by a public health authority, and you have to follow a bunch of other rules. So there's policy being set, privacy policy being set by Apple and Google. I tend to like the decisions they made, but it is being set by these companies rather than by, say, a government authority or public health authorities. And Google and Apple tend to be very strong on the privacy side of things here, but it's their decisions as to what it takes to get an app approved to be sold in one of their stores. And then there's a question as to, does this app get turned off when the pandemic is over? There's going to be another pandemic after this one. Maybe you should have the pandemic just loaded in, ready to go. Maybe it should just be turned off. Maybe just the data should be erased. What are the policies for what happens when the pandemic is over, assuming it's over? I mean, this could be chronic if we're not careful. Assuming we beat it somehow. So in conclusions, we've come a long way since COVID-19 appeared. We've got decentralized privacy preserving protocols. We've got a much better understanding of Bluetooth phenomenology, although it's not yet working as well as I had naively expected at the beginning. We've got Google and Apple collaborating on an API to support notification. Yet there's still lots of challenges, including the technical ones of ranging. There's dealing with the fragmented nature of US healthcare, many states, many jurisdictions. And so you can imagine many different apps being rolled out in the US at different places. And achieving sufficient adoption rates is going to be one of the big challenges for these apps as well. But there's lots of legal and privacy issues too, as I mentioned, and I look forward to questions. And that's really what I wanted to say. I hope that's stimulating, and look forward to the questions later.
Thanks, Ron. And I think that we are now going to pass the baton to Helen. Helen, are you there?
I'm here.
Okay, there you are. Hi.
I'll take, oops, sorry.
Yes.
I'll just take a moment to set myself up, and I'll share screen for my.
And after you, there will be a Q&A, which.
Wait a sec. All right, hang on. I have to do things in the right order. And does that work?
Perfect.
It's good.
Hi, everybody, and thanks to the organizers for including me in this event. First of all, thank you, Ron, for one of the best, if not the best, discussion and description of digital contact tracing that I've ever heard, and I've been a bit obsessed with it and going and bothering people to explain how everything works, and reading and watching webinars. And your talk was incredible, and my main failure here is going to be to try and remember everything you said and make sure that it's relevant to the comments I'm making. And of course, I look forward to challenges and questions. So as some of you know, I'm a philosopher, and I have been thinking about technology and ethics for many years. What I wanted to do is a little bit of a teaser, because the issues of values in design, which I'm going to, or values at play, are quite relevant as a methodology. And so while I'm going to come to the issue of contact tracing, I also want to cheat a little bit and introduce some of the theory of values in design. And as many of you know, there's a complicated relationship, between society and societal values on the one hand, and technology, high tech, and in our case, we're thinking about digital technology on the other hand. And over many decades, there have been philosophers, social scientists, lawyers, social critics, who've been talking about technology and societal values. Sometimes they stand on the outside and they look in as technology is something different, taking an external perspective. But the work that I've been doing, and I want to say an emergent, well, it's been slowly emerging and sometimes very much in the shadows, is a school of thought or a way of seeing technology through the lens of societal values that actually seeks collaboration and considers it impossible to talk about ethical and political values embedded in technologies, or the impacts of technology on society, without working hand in hand and without collaborating with the scientists and engineers of computing and digital technology. So it's very much a hope of working in partnership with the technologists. And the general framing of this idea is values in design, where it adopts the position that ethical and political values can be actually embedded in digital technology. And one version of this, or one framework that adopts this starting position, is values at play, and that's the one I'm going to briefly describe to you, and then move to the question of contact tracing. And it assumes that it's useful for two things. One is to take into consideration existing technologies and tries to analyze or read values into those technologies. And the other one is to suggest that technologists, conscientious technologists who are interested, can take ethical and political values into consideration when they design and develop technologies. And this framework, values at play, suggests a collaborative approach to doing this. So the values at play framework involves three components. They aren't steps, so it's not first, second, third, but it's just three activities that look different from one another. And we've labeled them, and I should mention two key collaborators on this are Mary Flanagan, who's a games designer and a digital artist, and Daniel Howe, who is a systems designer, protester. He's faculty in Hong Kong, Mary Flanagan at Dartmouth. So there are three components in values at play. One is discovery, and another one is implementation, and the third is verification. So when we look at discovery, there are two activities that are part of discovery. One is the specification. The one subpart is specification of functional goals and values. When you're developing or analyzing a technology, you think about what's it for, and included in the what's it for can be values. You can constrain the way you develop the technology according to values. So, you know, the discussion of facial recognition, we say, yes, we want it to be effective, but we also wanted not to unfairly discriminate against certain subgroups. And you have then, as actually Deirdre had commented, once you've established or understood or listed the values you're interested in, you need to have a good sense of what your definition is, the conceptual clarity, the values, the definition of the values concepts that you're interested in. Implementation is when you have these values and goals that you're interested in, you're worrying about how do you operationalize into the design of the system, architecture, mechanisms, features, and so forth. And for example, with the TSA who want to develop software for scanning bodies as they're about to board planes, we want to have some kind of image that reveals the potential weapons that a person might have or in their luggage. But at the same time, sometimes you may have values that conflict with one another. And in the TSA case, it may be modesty or privacy are the values. And you need to think about how do you resolve conflicts in technology. And what we offer in values at play is that sometimes if you're inventive in your design, you can actually get both. You can dissolve the conflict. Sometimes you can't, and you have to compromise. And finally, you would need to trade off. Finally, the third component is verification, which is, you know, did it do what you wanted to do? And I'm not going to spend any more time on it. So this is the summary, discovery, implementation, and verification. Now we come to the question of contact tracing. And I was so happy, Ron, that you listed, you know, for us manual contact tracing, because finally things clicked into place when I started looking at the automated digital tools and had to check them back against the traditional contact tracing. What were the functions that we were seeking and what were the values? So some that I've heard people talk about that I think are important: individual health, how can it help individuals who are exposed or who are test positive? What kind of clinical learning can we take away, or scientific learning? What about population health? How do they affect our epidemiological models of transmission? How come the CDC is saying, less than 6 feet, greater than 15 minutes? How did they come up with that? That's the kind of thing you can learn from, and you can keep updating your models as well. At the same time, as you mentioned, privacy is really important, social justice, autonomy, and so forth. And so the question is, what should your digital tools be in order to achieve these functions and also be consistent with societal values? Now, some of you, I'm going to focus on privacy and show how the conceptual definition actually affects the shape of the technical system. So many of you know, privacy is contextual integrity. Doesn't agree that privacy is about control of information. Rather, it's about the appropriate flow of information, conforms with legitimate contextual, and in this case, health norms. And I use the word rules because I realized computer scientists got so confused when I used the word norms. And legitimate norms are those that promote stakeholder interests, and contextual in this way, in this case, health domain functions and values. Now, I hope, this is many books and many articles condensed into a single slide, but hopefully some of it will become evident. This is my final slide. Definitely not going to be able to get through everything. And I've actually lost track of how much time I've been using up. So here's where I slightly part company with Ron. If we adopt a definition of privacy as contextual integrity, then it may be okay to mandate the use of the technology by a legitimate authority. And heavens knows whether such an authority exists, even in government, because we're living in strange times. But ideally, you would need to mandate, otherwise the efficacy is just too low. And what's the use of it if 10% or 15% of people are utilizing the app or on top of the APIs? Then the flow of the COVID status is determined not by consent, but by individual and societal health needs. The exposure and further infection data flows, that is to say, if you were exposed and then you were later found to be positive, what information is shared? And I think, again, this question, like GPS, who the person is and so forth, to whom, for what, and under what constraints. And then who receives the information? Is it legitimate authorities? And here I think I also am concerned about the GAPL or the Google Apple API, which does restrict the continuation of the flow back to the public authority, because, and here I'm pointing to where the arrow is on the slide, how do you improve your epidemiological models of transmission if you don't insist that the information of both exposure and then coming down with the virus are cycled back to the public health authority? And then I go through the other like competing definitions of privacy is control, where subjects choose to install, says subjects choose what and whether and with whom COVID status is shared. Those exposed choose whether and with whom to share the exposure. and later infection status. And the argument here is that there's not a trade-off, there's no conflict, because once we decide what the appropriate flow is, and that is based on what it is that we need to achieve with these apps and APIs, then the most important thing we need to achieve as a policy matter is to restrict the recipient of the information to be very transparent and very clear about what the recipients of the information can do with the information. And that's it. Thank you.
Thank you, Helen. So I actually, so now it's going to be a Q&A, but I must say that I have the first question. What is it that you disagree with Ron about? I didn't understand exactly.
My disagreement with Ron, Ron assumes privacy. Ron asserts that privacy is control over information about yourself. And so you set privacy up as antagonistic towards some of the needs that the health authority or the public health has in order to achieve what contact tracing, manual contact tracing and automated contact tracing should contribute. If you consider privacy, so then you set it up as privacy versus whatever else the need is.
Got it. So I don't know, Ron, if you want to respond.
Sure. Yeah, I think that's an accurate perception of what I said. I think my views are probably larger than what I said in some sense too. I think one of the concerns that people have is that privacy is to be evaluated not just as designed and hopefully implemented following that design, but is the system subject to abuse, and in particular is the subject to abuse in a way that could abuse people's privacy, so that, for example, should the government change or in a way that would be inimical to people's privacy, could they take a system like this and change its implementation or change its usage in a way that would cause people's privacy to be abused? So there's privacy risks, not just for the design as proposed, but for the design as it may actually be used, or rather abused in practice. And so I think one of the concerns that technologists have is to design a system that can't be abused. And this may limit the kinds of epidemiological utility that Helen was talking about. There is a real trade-off there. I mean, the tension between epidemiological needs and perceived privacy needs is a real one, and these should be discussed. Yeah.
I think that it could, it's possible that the only disagreement we have is how we use our words, because the way I would frame it is to say, we have this epidemiological need, which where the models, just focusing on that for the moment, where the models can be improved when you have feedback. Maybe you were less than 6 feet, you were 5 feet, and so on. And then, 10 days later, you test positive for COVID. Now, unless we have a lot of this information going back to the public health authority in order to perform the analysis, we're going to miss out on even improvements.
That may be correct. Let me respond. I see where you're going with that. If I can engage in some dialogue here. We don't have digital contact tracing as the only source of information, though. I think these systems are all intended to be fielded in a context where digital contact tracing is working alongside of manual contact tracing. And I haven't seen any argument that says that manual contact tracing can't provide adequate statistics to inform the development of appropriate epidemiological models. So I think,
sorry,
totally
I agree with, I like that image of the digital contact tracing or exposure notification, if we want to be more precise, working within a larger manual contact tracing environment. The main thing I want to do is preserve the use of the word privacy. So it's true that information can be exploited, information can be abused, and so on. So the most important thing that we all want to do in the name of privacy is to ensure that the information flows in an appropriate way. And that is according to the ends and purposes, not according to whether individuals consent or not. So I think, like, I know that
just to be clear, yeah, my thoughts on implementing privacy are not only oriented towards individual discretion, which is what I emphasize in my talk, certainly, because I do feel that's very important. But there's also privacy controls from the beginning in the design of the system. So Google and Apple in particular don't allow an app to have GPS information, for example, which could be useful and very useful for some of the epidemiological needs, looking for super spreading events and so on. So there are technical means that are not individual discretion, but choices made at the design time, which allow control information flow. And so I think those are maybe the more important ones in some way, well, at least as important for trying to assess some of these questions. So there's both design level decisions and then operational decisions made by the parties in the middle of the implemented design.
I'd like to open the floor to other questions. Are there people just unmute themselves and speak? We will do it this way.
Hi all. Can I take the floor, Michael? Is that okay? So hi everybody, it's wonderful to see so many familiar friends and faces here. And a couple of questions please for Ron and Helen. It seems that the concern about the location GPS-based apps, other than whether they are effective or not, which is obviously important from the privacy point of view, is the government, the state. And there are other aspects of privacy. Many people are concerned of their data being collected by the cell companies, the mobile service providers, and of course Google and Apple. So that is another concern which I'm not sure I heard enough of. Now, maybe there are good technological ways to deal with that, with encryption and whatever, anonymization, if it's possible. So I was wondering about that. And to Helen, there's much I like about contextual integrity, but I do have my critique, as you know. And I was wondering, in this context, why is this only a health context? Because the data emanates or is created in the context of a commercial setting in which I pay for the mobile service provider, and some of the data is created by me just using it in my daily life. So that's one context which becomes a health context. There are two contexts here that merge, and also there's the social context, because if the data collected is about proximity of people, even if it's encrypted, etc., assuming some smart guys like some of you in this room can find ways to re-identify people and hence contacts, and that might expose, whom am I in a relation to, who do I see, etc. Not only the stranger that happened to sit next to me on the bus or whatever. And so I would argue that there are at least three contexts here. The commercial of us using the phone, the social, us and other people, and then it becomes a health context. And what I've heard, the subtext, or in my ears, was some sort of balancing that you conduct with as you define the transmission, the informational transmission rules of the health context, but it's a mixture of contexts. And just to add to that, and with that I will conclude, resistance. In Israel, there are many people who say that they stopped carrying their cell phones with them. And we have some, security surveillance going on and some other things. But people want to avoid being misidentified in various places, so they just don't carry their phones with them, which is not very helpful in managing the pandemic. Thank you. Sorry.
Maybe I could respond to the earlier part of your questions there. You were talking about privacy concerns with respect to, say, Apple and Google too. I think as a rule, cryptographers tend to be professionally the most paranoid people that I've met, right? They are used to thinking about all the ways that things can go wrong and what happens if this party or that party or this collection of parties should be bad actors or colluding with each other and so on too. So these are kinds of scenarios that cryptographers do think about daily, and it's the kind of thing that informs what's happening here. So in particular to your question, what happens if Apple is a bad actor or Google is a bad actor? Those are the kinds of things that are explicitly considered in the design of these protocols. And Apple and Google do not, in their databases or the design of the protocols, put themselves in a position where they are in any way privileged with respect to personal information. They can't identify people. They can't find out where people are or who's been talking to whom. These are anonymized, random identifiers. So the questions you're asking are good ones, but I think that to the extent possible, the cryptographic design of these protocols protects privacy, at least as the cryptographers understand it, by abuse by the parties involved to a large extent. There are some active attacks where people try to, for example, let me mention one that's interesting that I think may need to be addressed in a future version of this. Somebody could go into a doctor's office where people are about to be tested. They could listen to all of the chirps of their phones and then go somewhere else to a subway station and rebroadcast those chirps for other people to hear. And then when the person tests positive that was in the doctor's office, those other people at the subway station think, well, they might have been exposed. So that's not a privacy concern maybe, but it's an operational concern. So there's those kinds of attacks where people think about active attacks. So I think the concerns you raise are good ones, but I think these protocols, to the extent they can be addressed by protocol design, tend to be pretty well handled by these protocols. The protocol level, the privacy protection level, is in fact the least of my concerns about all of this digital content tracing stuff. I worry more about, I lose sleep over other aspects of such as measuring distance or adoption rates and so on too. Those are the harder ones. I think we can handle the privacy ones pretty well.
What is the notion of privacy here? For instance, if my interaction network is very sparse, I interact with one person and I get a notification that one of the chirps is positive, then now I learn that this person is positive.
I think the useful definition, and it's the kind of definition we see a lot in cryptography, is that the digital contact tracing privacy standards should model the manual contact tracing standards. So you have exactly the same issues with manual contact tracing. If you get a call from a contact tracer saying you might have been exposed, and you know that you've only been in the presence of one person over the last 2 weeks, well, you know who you might have been exposed by. So it's exactly the same.
I think that fundamentally, I have a problem with that answer because maybe I want to keep open the question of whether you inform the person who it was or where it was that they were exposed. If you think about the goal of contact tracing, or even if you think about different diseases, like think about sexually transmitted disease, where contact tracing has been a very important tool. If you actually want to intervene in the spread of the disease, then actually you may want to give the exposed party more information about who they were exposed to. The time it would take to properly respond to Michael is more than we have. But I just wanted to talk about the commercial situation, and I have been concerned about privacy in relation to Google and Apple with mobile devices, because I think that we're very vulnerable. And so I sort of hoped like maybe this is a moment in which people will pay attention to how much leakage there is to Google and Apple. And I tend to maybe have less trust because I think there's a lot of exploitation of data by those companies. So yes, there is that different context. And yes, we need to make those determinations about what prevails. And maybe ask Ron this question about the database, whether it's a matter of technical impossibility for Apple and Google to use the key that I believe they're generating to reconnect the phone identities with the information that's in the databases, or is it just a matter of policy that they say, we're not going to do that?
So you are, as a phone owner, you would be trusting Apple and Google to implement the design as published, which doesn't, I mean, once you've got a device made by somebody else, you know, if that party is a bad actor, they can turn on the microphone, they can turn on the camera in ways you don't know, whatever, they can do all kinds of ways of invading your privacy. So you are trusting the manufacturer of that phone and the software on that phone to honestly implement the designs that you think they're implementing. That's, you know, that said, I mean, this particular protocol, if implemented according to the design, is not one that gives Apple and Google any particular advantage or privilege with respect to identifying people or their contacts. It's a very narrow protocol. It uses these randomized identifiers. There's no way that I can see how they could make use of the database information in the database to de-identify people without other information. I mean, if you start putting in other information, you know, maybe there could be something. If you have somebody tracking somebody and following them around, you know, that there's a lot of information coming into play there. I'm not sure that it's been carefully studied, but I don't see how the digital contact tracing would add any advantage to somebody trying to do that kind of tracking of somebody. But these are worth looking at. They're carefully designed, and these identifiers change rapidly. So I don't think there's much leverage that anybody gets by trying to fool around with the database or listening to just these random chirps without doing something active.
So it's 10 o'clock, and I just wanted to say something about the topic, but then we will separate. We'll have a break for 15 minutes, and then we come back. We'll be separated into groups where we have sort of different topics: privacy challenges, public-private interface, voluntary versus mandatory aspects, and transparency and accountability. But I just wanted to say something that, so in some sense, Ron, and I think it would be natural approach by a cryptographer is to take the extreme privacy perspective, where, Ellen, you're bringing up issues that obviously we all realize are important, but they are difficult to define. Like, what is it that you are willing to release, and then how would you cryptographically match that? I just want to mention that there is a whole framework of how to define these things also within cryptography, which we call sort of ideal versus real. So if you had a formulation of what the ideal world would be, that is how much information you want to give, and nothing but, okay, and then there's sort of a definition of how would you match that in a real world by a protocol, and then we also have methods of proving that what you have actually matches that. But it starts with actually formulating what it is that the ideal world you want to provide. And that is, you know, I think that we often run into a problem that when we are dealing with a real situation, okay, that people who are advocating for giving more, releasing more facts and or don't formulate it. So if they did, if they were able to, we often could match it by technical means. All right, anyway, so a break. You can go have coffee or whatever it is you do, lunch, depending on your time zone.
Can I ask a quick question? The chat stuff that's on the side, or I mean on my side, is someone, is that also recorded? Because it's so useful, but I haven't been able to monitor it.
Yes. I mean, I don't know. Yes, I assume so.
I can keep this. Yeah, I'll keep it in recording.
Okay, great.
There's a save chat button down at the bottom, at least in mine. If you click the three dots at the lower right, it says save chat. You can save the.
Cool.
Oh, cool.
I'm not sure where that gets saved exactly or how you get access to it.
Okay.
It's totally private. Yeah.
This is from Ron. Okay, in any case, I feel much better now. So in 15 minutes, don't be late. It will be interesting.